Welcome! In this video, we are going to learn about the addition, subtraction, and multiplication of polynomials. This is the learning outcome. Polynomial is written in this form, where n is the degree of polynomial and a positive integer. A sub n until a sub 0 are constant called the coefficients. A sub n is not equals to 0 and is called the leading coefficient. A sub 0 is the constant term. The examples of polynomials with low degrees is shown in this table. We notice that all of the power of x are positive integers. The example of non-polynomials are shown in this table. 1 over x can be written as x to the power of negative 1, where the power is negative. And cube root of x in index form is x to the power of 1 over 3, where the power is a fraction. Polynomials can be added or subtracted by collecting together terms of the same degree. Unlike terms cannot be added or subtracted. In this example, we want to find p of x plus q of x and p of x minus q of x. To solve this, we substitute the given polynomials, open the bracket, then add or subtract the terms of the same degree, and we get this answer. For p of x minus q of x, we follow the same step. But this time around, the sign changed when we open the bracket. Now solve it. When two polynomials are multiplied together, each term of one polynomial is multiplied by each term of the other polynomial. In this example here, we want to multiply a constant 6 with a polynomial px. Just multiply 6 with every term in px, then we get the answer. For this example, we want to multiply two polynomials. Substitute the polynomials, then expand one by one. After that, add or subtract the terms of the same degree to get the answer. This is the learning outcome. To divide a polynomial by another polynomial containing more than one term, a procedure called long division is used. In general, the long division can be depicted as shown in the diagram below, where px is the dividend with degree n, dx is the divisor with degree r, qx is the quotient with degree n minus r, and rx is the remainder with degree less or equals to r minus 1. When we multiply this equation with dx, we will get another form of equation without the denominator. In this example, we want to divide px by dx. So put dx on the outside and px on the inside. To do the long division, we follow the three steps, which are divide, multiply, and subtract. So first thing we need to do is to divide x cubed by x, and we get x squared. Then multiply x squared with the divisor x plus 5. We get x cubed plus 5x squared. After that, subtract the px with x cubed plus 5x squared, and we get negative 3x plus 10. Now we will repeat the same steps. First, divide negative 3x by x, we get negative 3. Then multiply negative 3 with the divisor x plus 5, we will get negative 3x minus 15. After that, subtract the negative 3x plus 10 and negative 3x minus 15, we get 25. And the process stops here because 25 cannot be divided by x. From this long division, we can get the quotient, which is x squared minus 3, and the remainder 25. We had to write the answer in this form. So just substitute all the expressions into the equation. To solve this, put dx on the outside and px on the inside. We add plus 0x so that it is easier to subtract later. So first thing is divide x cubed by x squared, we get x. And now multiply x with the divisor. and we get x cubed plus 3x squared minus 7x. After that, subtract px with x cubed plus 3x squared minus 7x. We get 7x plus 8. Now 7x cannot be divided by x squared, so the process stops here. So the quotient is x and the remainder is 7x plus 8. Then state the final answer. For this example, we write the denominator on the outside and the numerator on the inside. Then repeat the steps like the previous example. First, we divide 6x cubed by x, we get 6x squared. And then multiply 6x squared with the divisor, we get 6x cubed minus 6x squared. Now, subtract px with 6x cubed minus 6x squared. And we get 4x squared plus 7x plus 5. Divide 4x squared by x, we get positive 4x. And then multiply 4x with the divisor, we get 4x squared minus 4x. Then subtract 4x squared plus 7x plus 5 with 4x squared minus 4x. And we get 11x plus 5. 11x still can be divided by x, which equals to 11. So now multiply 11 with x minus 1, we get 11x minus 11. After that, subtract and we get the remainder 16. Since the question is in fraction form, so we write the final answer in this form. Substitute all this expression and we get the answer. Please submit this exercise before class ended.